Assalamualaikum everyone. In this video, we will look at subtopic 6.3 application of arithmetic series and geometric series. At the end of this video, all of you must be able to solve problems involving arithmetic and geometric series. Now we go to example 23. A taxi ride can cost you a fixed charge. For the first 1 kilometer, it can cost 3 ringgit and the next subsequent kilometer could cost you 80 cents per kilometer. Calculate the total cost that you should pay if you travel 5 kilometer. First of all, we need to take out the important information here. We are given the first kilometer is 3 ringgit and the next subsequent kilometer is 80 cents. So, we have T1 equal to 3 and D equal to 0.8. We know that it is an arithmetic progression. To calculate the total cost if you travel 5 km, we need to find S5. And the formula of Sn is equal to n over 2 times 2a plus n minus 1 times d. Substitute all the values and we get 23, means that the total cost is 23 ringgit. Example 24. A trapezium-shaped theatre is designed such that the number of chairs in successive rows are in arithmetic progression. The first row of chairs contains 12 chairs and the last row contains 63 chairs. There are 18 rows altogether. First, find the number of chairs in the theatre. In this question, we have A equal to 12 and there are 18 rows, means that n equal to 18. But we don't have the common difference, which is D. Given that also the last row contains 63 chairs. So what we have here is T1 equal to 12 and T18 equal to 63 because altogether we have 18 rows. Substitute into the formula, just substitute the value of A and N, so we can get common difference, D equal to 3. Next, we can find the number of chairs in the theatre, which is S18. Substitute into the formula and we get S18 equal to 675. Second question is, find the number of chairs in the fifth row. We need to find T5. Just substitute all the values A, D, and N, so we get T5 equal to 24. Example 25. A pendulum swings through an arc of length 40 cm. On each successive swing, the length of the arc is 0.95 of the previous length. First, what is the length of the arc after 5 swings? Given that in the question, A is equal to 40 and R is equal to 0.95. The question asks to find T5. Substitute into the formula of Tn, which is AR to the power of n minus 1. We have T5 equal to 40 times 0.95 to the power of 5 minus 1. So calculate, we get T5 equal to 32.58 centimeter. Part B. At which swings is the length of the arc of the pendulum less than 15 centimeter for the first time? So we are given that Tn less than 15. The formula of Tn for GP is A times R to the power of n minus 1. We have A equal to 40 and R is 0.95. Move 40 to the right hand side. So we get 0.95 to the power of n minus 1 less than 3 over 5. To solve this indices problem, we need to log both sides and check the value of log 0.95 before we simplify these inequalities. And take note that this value is negative. What will happen here? This sign will change. And solve, we get n greater than 20.12. Since n is the number of terms, and remember, it must be positive integer, therefore, we approximately n equal to 21. The length of the arc of the pendulum less than 15 cm for the first time on the 21st swing. Part C. Find the total distance covered by the pendulum after 20 swings. So, we want to find total, means that S. For part C, we have to find S20. Substitute all the values into the formula and we get S20 equal to 513.21 cm. For part D, find the total distance covered by the pendulum before it comes to a stop. We didn't know at which swing the pendulum will stop. So, it shows that we need to find S infinity. So, the S infinity is equal to 800. Example 26. A ball is dropped from a height of 200 cm and bounced up from the floor to 0.9 of the previous height. Part A. How high will the ball bounce up immediately after it hits the floor for the 5th time? So we need to understand this question clearly. The ball dropped from the height of 200 cm. This is our T1. So it will bounce. The height of the ball after it bounces will be 0.9 from the previous height. So this is our T2. But you must take note that it is the first time the ball bounced from the floor. So how to get the 5th times? Look at here. This is the 2nd time the ball bounced from the floor. It is the 3rd time. This is the 4th time. And this is the 5th time. You can see that actually we want to find T6. For part A, by using A equal to 200, R equal to 0.9, find T6. So we get T6 equal to 118.10 cm. Part B, how many times does the ball need to hit the floor before it bounces to a height less than 50 cm? So given that in the question, Tn less than 50. To solve the indices problem, we need to log both sides and note that this value is negative. Therefore, the inequality sign will change and we approximately get n equal to 15. But remember, n equal to 15 here is included when the ball is dropped from the height of 200 cm. Therefore, the ball needs to hit the floor 40 times before it bounces to the height less than 50 cm. This is the end of topic 6. Hopefully, all of you get what we have been discussed before. That's all. Thank you.